Hi, welcome to this video on our contracts component of our Corda distributed application, our CorDapp. So we saw earlier that in Corda, the ledger is a set of shared facts, and the ledger is updated over time. So nodes update the ledger using transactions. A transaction is a proposal to modify the current ledger in some way. So a transaction is a proposal. To update the ledger, the transaction has to be validated. So a transaction consumes some kind of existing input state. So there is an input state. Maybe I have $10 and then I pay that $10 to Tom. So me having the $10 is marked as historic. I can't use that $10 anymore. That $10 has to be used by Tom, and that will be the new state of the ledger. If a transaction proposal is approved, the input states then are marked as consumed or historic. Again, I can't use that $10 anymore. While the output states are created and they become the current state of the ledger. So now any new transactions with that $10 will begin with this state because this is the new state or the new state of the ledger. So if we look at this a little bit bigger here, we can see that there are input states. These could be payments, these could be transfers, could be real estate, healthcare, many different types of assets. We don't have to begin with an input state. We can just strictly have an output state. And you can see that just like we had that example where I made a payment, that person then makes a payment to somebody else, and that all these transactions evolve the state of the ledger over time. So the future transactions update the ledger over time. And when approved, the output states will become the new state of the ledger, and the former or the original input states will be marked as historic. They'll still be there for historic purposes, but they cannot be used in any transactions. Transactions can be ambiguous, so just by looking at the transactions and the input and output states, it can be hard to tell if what the transaction is doing. For example, we see transactions with cash inputs and bond inputs and cash outputs and bond outputs. What is this? Is this a bond purchase, a payment on a coupon, or something else? It's hard to tell what the transactions represent. So Corda gives us commands. So to clarify the intent of a transaction, we use one or more commands. The commands say what the ledger updates actually, or what the transaction represents. So for example, in this transaction, the commands indicate that we are transferring cash from one party to another, and we are also doing this to make a payment on a bond coupon. So in this transaction, we see that it is representing doesn't represent a bond purchase. It represents the payment on a bond coupon, and that's what the proposal is. So we can also see here each command, and again the commands, is associated with a list of required signers. So right here we need the input from the owner, and we see owner here Alice, and then we see owner here Bob. So the cash transfers must be signed by the owners of the cash. So we need an owner here and an owner here. And the coupon payments must be signed by the bond issuer and owner of the bond. So the input here is the owner and the issuer of the bond. So we see here the owner and the issuer and owner and the issuer. For this transaction to be validated from a proposal, the signatures must be gathered from all of the required signers that are indicated in the commands. So in this example, we need to gather signatures from the cash owner, which is Alice, the bond owner, which is Bob, and then the bond issuer, again, which is Alice. In other words, Alice and Bob would be required to sign this transaction to make it valid and to have the ledger updated. So our Corda API, so our commands with parties, so our commands are implemented with the API commands with parties, and our inputs and outputs are implemented with the ledger transactions. And it's time for a demo. So if we take a look here at our contract class, you can see here our contract class implements the contract interface. We can see here our commands. So in this case, we have issue, transfer, and settle. These are our commands. And if we scroll down here, we can actually see these commands in place. So we see the command issue here a little bit later on in this function, or this would be the equivalent of a method in the Java world. Scroll down here, we can see the command transfer, and there are requirements associated with the transfer. We'll talk about that shortly. And we see the command settle and some requirements there. So you can imagine as these commands are being executed, there are certain requirements that need to be met before the transaction is validated. So again, we can see here that this is quite straightforward. Please read the comments as you go through. That'll be part of our assignment, is to read the comments on all of these so we gain an understanding of the logic. The coding we can always pick up, but understand the logic about what is actually running here. And then the commands will also, like we said, will gather signatures. So if we read through here, you can see that we do our checks, and then we are then checking on any kind of property changes. And then down here we have our signers and our participants. So our contracts have the logic in here to decide if the transaction's proposals are valid. Again, here is a transfer of cash from Alice for the amount of 3, transfer ownership to Bob. So the first thing, has one cash input and one cash output. Is that true? Well, yes, we see it's true, so we see the check mark there. Then we see, do we have a transfer command? Well, we can see the transfer command there, so that gets checked as true. Is there cash in and cash out? So it looks like that's the case here. There is a cash input and a cash output. And do we have the input owner requirement signature? We have that, so that gives us a valid transaction. And then the ledger would be updated that now Bob is the owner of this cash of the amount 3. So let's take a look at this transaction. Again, we have our inputs and our outputs. We have our owner Alice with 3, and well, let's just go through this. So rule 1 or requirement 1 has, do we have a cash input and a cash output? Seems to be the case. Yes, that's true. Do we have a cash transfer command? Yes, we do. And we need the command is requiring us a signer. Do we have cash in equals cash out, and this means equals here. Cash in 3, but cash out is this amount here, which is almost $1 million. That's a problem right there. That's what we call a contract verification exception. Obviously, this would be an invalid transaction, and the ledger would not be updated, and it would roll back to its current state. So we can see here that to input these requirements, again, that is the requirements are implemented in the contract type. And I'm going to do a demo. So here we can see we've opened up again our contract class, and here we can see our commands. And it says here that no inputs should be consumed when using an IOU. So we could see here it's just checking for empty. Only one output state should be created. So we see here output states equal to 1. A newly issued IOU must have a positive amount. So the amount here is greater than 0. We can see that rule. The lender and the borrower cannot be the same person. I cannot lend to myself. So we see here IOU borrower not equal to IOU lender. And if you look through here again, read the comments, it's quite straightforward here. We could see some other only the lender property may change. So we can see here we're calling back the lender property. So to update the input and the output. So you can go through here and check that the cash out is being assigned. So you can take a look here at these inputs and outputs that actually validate a transaction. It all, again, is quite straightforward and makes a lot of sense. And all of these are running within the, notice, within the commands. So the commands are validating all of the rules and the requirements for the transaction. We'll actually summarize all of these rules. But before we get into that summary, we can see here this very first requirement here: no inputs should be consumed when issuing the IOU. So there should be no input states, and we're validating here that the transaction inputs are empty. So, well, here we go. Here is a great simplification of what we just looked at. So here is our IOU issuance transaction, no inputs. We have that rule that we saw, and you can go back and take a look again. The amount has to be greater than 0. We have one command, issuer, with a required signer. And again, the output needs to be positive, and here are our participants. So it doesn't really make sense to for an IOU to equal 0 or less than 0. Again, here, if we look through all of our IOU contract, that class that implements contract, we'll see there are no inputs, one output. I think we just saw that on the previous. So we have that one output command, or one output state. We have the one command. Again, we see the one command and the one output state. Well, we see that right here. Output is the IOU state, and the output field is positive, and the command is issue. So we see here the command is issue, and we have a issuer is the required signature. So as we go into our exercises, what we're going to do is go through each of the files that make up the classes, and we don't have a real Corda node or a Corda certificate. It's just not practical, but we can do a simulation, and we will do a simulation. So we're going to use our repositories, the Corda Training Template Master and the Corda Training Solutions Master, and then we are going to run the unit tests on all of those to simulate the execution. So again, to summarize what we saw, transactions consume old states on the ledger and create new ones, or sometimes there are no old states, there's just new states come into existence. Commands indicate the intent of the transaction and also indicate the required signers. Contracts are classes implementing the contract interface, and contract classes should verify transactions and validate that they are indeed valid. So if any rules are broken, a validation exception is thrown.